GMAT all day.
Up until now, we have been talking mostly about lines and linear equations in the coordinate plane. So let's talk now about angles, and we'll start by talking about vertical angles. So what are vertical angles? I have no idea why vertical angles are called vertical angles, because what they are is they're just angles that are formed when you have two lines that crisscross each other. And so pairs of angles that are across from each other are called vertical angles. And so this A and this B, A and B are vertical angles to each other. But the reason I have no idea why this is called vertical angles, so I thought initially they're called vertical angles because A is on top of B, but we also have a C and a D here, and C and D are also vertical angles to each other. So I have no idea why they were given the name vertical angles, because they could be horizontal. The thing to know, though, about the vertical angles are equal to each other. So A is equal to B, C is equal to D. And this is not hard to prove, because if you just know that two angles that form a line must add up to 180 degrees, therefore we can say this D here is really just 180 minus A, which means this B here is going to be 180 minus 180 minus A. So once you simplify this, the 180s cancel out, and you have a negative times a negative, and you're just left with A. And so this here is equal to A, and then you can do the same thing to get C and D are the same. So those are vertical angles. Pretty much the only thing you need to know how to do with them is A, recognize them, and then know that they are equal to each other. Another common rule involving angles is when you have two parallel lines, they're cut by a transversal. So that's just the line that crosses both of them. Called a transversal because it traverses both lines. And so when you have two parallel lines cut by a traversal like we have here, the thing to know is that the angles that are formed are going to correspond to each other. And so which angles correspond to each other? So I think of this like as if I have two coordinate planes that have been formed here, an upper coordinate plane and a lower one. The quadrants that are formed are the same. And so if my upper right quadrant here should be equal to my upper right quadrant here, which means this angle here should match this angle here. This angle here should match this angle here. Bottom left quadrant here should match my bottom left quadrant here. And then my lower right should match my lower right here. And so note that everything, in order to do this, in order to think of this as two sort of coordinate planes to match up your angles, everything is relative to the parallel lines. And so this is the way I like to orient my diagram with my parallel lines horizontal like this, because otherwise you could easily make a mistake such as this. So they don't have to give you the diagram looking like this. They can give you something like this, where you have two parallel lines like this, and say these are the parallel lines now. Say instead of giving you two lines that cut these, or say instead of giving you a single line, they give you two lines. So they don't tell you these lines are parallel. They might look parallel, and they could be parallel, but they don't tell you that. If you do this, you might just say, oh, this is that diagram that Adam was talking about, where you have parallel lines cut by a transversal, and so you just need angles that correspond to each other. And so you might say, so like this angle here, for example, matches that angle there, but this is actually not true, because remember, everything is relative to the parallel lines. And so if you were to flip this diagram 90 degrees, that your parallel lines would now horizontal. You'd see that those two angles here is like comparing these angles, and these two angles have nothing to do with each other because your coordinate planes are formed based on the parallel lines. So don't make that mistake. In order to orient yourself, make sure everything, all your similar angles are relative to the parallel lines, not the reversal line. So let's do a GMAT question involving that rule. What is the value of A plus B plus C. So we're just given this diagram, no information whatsoever, literally just a question. So no values or anything. Then we're going to find this value. In my head here, I'm not necessarily looking for the values of A, B, and C. I highly doubt it is going to be possible to find those things. In fact, I don't even think we're going to be able to get any of them individually. My goal is to just form any equation involving A, B, and C equals something. And then I'm hoping that I can rearrange that equation to get to A plus B minus C. And hopefully A plus B minus C equal to a number. So a note from this diagram here, if I see this diagram and I'm thinking, okay, it looks like that the parallel lines cut by a transversal rule. I do not know yet, though, that I have parallel lines. I do not know that DE is parallel to FG, at least from the prompt. And so do not make that assumption. Wait for them to give it to you before you say that, or else you'll jump the gun. So statement 1, lo and behold, says DE is parallel. This is the symbol for parallel lines. DE is parallel to FG. And so I might redraw this diagram down here. Actually, if I go back to my prompt, so I don't know these lines are parallel, but if I just want to label everything I do know, so I do have some vertical angles, right? I could say this here is another B, this is C, which means this is 180 minus C. This is another 180 minus C. I have 180 minus B, A minus B here. So that's all I can sort of label for now. Can't tell anything about angles up here until I get to statement 1, because this is now where I find these lines are parallel. Now I'll redraw this. Now I know these are parallel to each other. So what can I say now that I know a DE is parallel to FG? And now I can start to fill in some information about my angles up here. And so based on my coordinate planes, I can say, so this angle here corresponds to my C. There should be another 180 minus C here. Here's another C, another 180 minus C here. This here should be a B. Here's another 180 minus B, another B, another A minus B. So if I'm looking for equations with A, B, and C, I see I have one here, because this polygon that is formed by these crossing lines here is a triangle, and I have all the angles labeled for my triangle, and I know the sum of those angles should be 180 degrees, and so this here is an equation. So I know that A plus B plus 180 minus C is equal to 180. And based on this information, subtract 180 from each side, A plus B minus C is equal to 0. This is exactly what I am looking for. Don't know A, don't know B, don't know C, but I can find A plus B minus C based on just the first statement alone, which is pretty amazing, because all the statement did was tell us these two lines are parallel. It didn't give us any equations or any numbers whatsoever, and yet it ended up being sufficient. Now, I don't have to worry about because the statement was sufficient, I don't have to worry about erasing anything on this diagram, so I can just keep adding here. So statement 2 says B plus C is equal to 180. Now remember, I don't know DE and FG are parallel for statement 2 by itself. So is there anything else I know other than what I was given in the prompt? And I don't think that I do. And so I don't think I can really do anything with this, because my left and right sides here aren't really connected in any way. So there's no equations that I can form or inferences I can make. If I could get these two angles here, this here is a quadrilateral, and so that should sum up to 360 degrees. But I don't see any way I can do that. I certainly, my top half here is completely disconnected from my bottom if I don't know that DE and FG are parallel. So I don't think there's anything I can do here, and statement 2 is insufficient based on that. And so A is the answer. And so that's pretty amazing, because statement 2 is the one you would think it would be sufficient just by looking at the problem, because statement 2 actually gives you an equation Statement 1 gave us no equation whatsoever. That just goes to show that your geometry rules, they're there to give you information. And more information, usually, if you know what you're doing, is there to make your life easier. So know your geometry rules. On to the next video.